Hello and welcome to Chapter 13, Section 8, Reciprocal Trigonometric Functions. So sine, cosine, and tangent all have a reciprocal function that has a specific name. Okay. The reciprocal of sine is cosecant, the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. Now it's easy to remember cotangent with tangent, right, because they both have tangent in it. When you try to remember the reciprocal of cosine, it's secant, right? And the reciprocal of sine is cosecant. So if you think about it, they're the opposite, all right? They switch letters, essentially. Cosine becomes secant, right? So C becomes S, and sine becomes cosecant, so S becomes C, if you need an easy way to think about it. Now, when we do this stuff, we need to know that. We need to know that off the very top of our head. So it should be very apparent when you look at something that says cosecant that you're talking about 1 over sine. And then they have short letters that tell you what it is. So cosecant is CSC, secant is SEC, and cotangent is COT. And that's important. That's important for you to remember. Now, when you're trying to find cosecant of 45, like we are in example 1, a lot of times you can just plug it into your calculator. And that makes it very simple. So cosecant is in your calculator, right? You plug in 45, and you end up with about 1.41. Now this is an approximation. Okay, later we'll find the exact value, right, in example 2. For now, let's find the approximation. Now if cosine is 4 over 5, and we need to find secant, well, we know, based on that table above, that secant theta is 1 over cosine theta. So this is just 1 over 4 over 5. And when you put 1 over a fraction, you flip the fraction. So the answer is just 5 over 4. Right? And it's not going to be much harder than that. Now, the hardest thing might be something like example 2, where it says to find the exact value. And when we're finding the exact value, that's when you go back and we're using those reference angles and, you know, special angled triangles. So let's draw this. Well, 45 degrees is here-ish. There's your 90. That's 45, which means that's 45, which means the hypotenuse is S root 2, and the sides are S. So once we can get one of them, we can get the rest. Now this is on a unit circle, so S root 2 is equal to 1, which means, right, because that's the radius, and on a unit circle, the radius is 1, just in case you forgot. So knowing that, that means that S root 2 is 1, so S is 1 over root 2, and remember, we can't leave a square root in the denominator, so you multiply by the square root of 2 on top and bottom, and you get root 2 over 2. Alright, so that's S, which means that this distance is root 2 over 2, and this distance is root 2 over 2. That's going to help us out. Now we're going to think about, okay, well, what is cosecant? Well, cosecant is 1 over sine. So we're really trying to find 1 over sine of 45 degrees. And we know what that is because sine, if you remember, is the y coordinate. So it's going to be this one. Now, and really in this case, because it's a 45-degree angle, it doesn't matter too much because they're the same. So we're just going to put 1 over root 2 over 2. And like I just said above, when you put 1 over a number, a fraction, it flips. So this becomes 2 over root 2. Right? Well, again, you don't want there to be a square root in the denominator, so you multiply top and bottom by the square root of 2. Which gives us 2 root 2 over 2. Well, that means that the 2's cancel, and the answer is just the square root of 2. So the square root of 2, it must be about 1.41. Okay, and that makes sense. So, let's keep going. A lot of the time, if I ask you to find an exact value, that's what I expect you to do. If I don't tell you to find the exact value, or if I tell you to use a calculator to evaluate the expression, like in example 3 here, and then round to the nearest thousandth, I definitely expect that of you. Now, remember, if it doesn't have a degree symbol, it's in radians. So we're actually finding both of these in radians, and you have a calculator that allows you to do that. So I'm just going to tell you what you would get. When you come to class, I will show you how to put it into your calculator if you don't already know. So A ends up being about 1.376, and secant of -2 is about -2.403. Okay. Now look at this, a word problem. Okay, but if you're freaking out because it's a word problem, don't. Most of the time, and as you've seen in this unit, when there's a word problem in a trig problem, or in a trig section, it's just been telling you essentially to plug things in. So let's see what happens. A handler of a parade balloon holds a line of length y. The length is modeled by the function y equals d secant theta, where d is the distance from the handler of the balloon to the point on the ground just below the balloon, and theta is the angle formed by the line and the ground. Let d equal 6. Find the length of the line needed to form an angle of 55 degrees. Well, if they tell us that d is 6, then we're really dealing with the equation y equals 6 secant theta. And they're asking us to find the length of the line. Well, the length is modeled by the function y equals this, where theta is the angle formed by the line and the ground. It gives us an angle. It says it's 55 degrees. So change your calculator into degrees. And what it's asking for when you plug in 55 is y equals 6 secant of 55 degrees. And again, don't forget, has to be in degrees. Now, I'm not going to put the equal sign because I'm going to plug this into my calculator. It's going to be an approximation, so that is about 10.5 feet. Okay, and you will see that when you plug it into your calculator. And because of your calculator, you can just plug it in the way you see it. And that's all. That is reciprocal trigonometric functions. Have a great day.